Hello everyone, greetings and welcome. I am quite excited about this video because this is the Church of St Michael's and All Angels in Moccas. Moccas is a small village in Herefordshire and is one of the most peaceful places I have ever visited. Unfortunately, I did not have my recording equipment set up when Lyndon, who is the director of music at the church, was talking about the organ's history. However, there is lots of information about the organ and its history on the church's website, including its restoration in the 1970s and in 2020. The organ has some interesting and unique features. It has a trigger swell box, a flat pedal board, but the main features are the separate pedal cases either side of the main organ, the case hand-painted by Kemp, which is a true piece of art, and finally is the hydraulic engine, which uses water to pump the bellows. Only a handful of organs have hydraulic engines that have been restored, although the one at Moccas is the only one of its particular model. Lyndon is now going to show us the hydraulic engine and the tracker action mechanism. And this is the mechanism for the manuals, which are the keys. And then I will then play a few pieces afterwards. I hope you enjoy this video as much as I have making it. And now over to Lyndon. God bless.
Are you recording now?
Yeah.
All right, okay, hello. We haven't got a light up here, but I just wanted to show you in here. This is the top of the reservoir, and I'm about to use the blower just to demonstrate something which is important in the way it works. So if you see the cable at the top there, which is right in the middle of the reservoir, there's a cable which goes up over a pulley, over there, and then down there. Now what happens there, along with all the cobwebs, is that when the reservoir is filling up, that cable moves up and over there, and then that drops a valve down. It's like a shutter valve that drops down there that shuts off the air supply from the blower, or indeed from the feeders through the hydraulic engine. It basically does the same thing to make sure the reservoir doesn't explode, because obviously you need a reservoir that is full but not bursting. So when it gets full, that valve closes and you'll see that the airflow through the organ is actually reduced. There's then the reservoir here. There are two things we're seeing here. So this goes directly to the pedals. So the pedals have their own air supply. This is a wind trunk that goes up to a second reservoir directly above here, and that is just to keep the organ pressurized so that it can handle, you know, a lot of playing. So the air flows through two reservoirs to get to the pipes, generally speaking, apart from the base, which has a separate wind trunk here. So there's another valve here actually that connects to the second reservoir. So when the second reservoir fills, this valve drops down and again shuts off the air supply so that there's not an extra SF pressure in the organ. So what I'm going to do now is I'm just going to use the blower to begin with. We'll start the blower. It's a very good blower, right at the new blower that was put in 2020. Very good blower, and it will inflate the reservoir quickly. It will then, the motor will slow down, and everything will start to idle because these valves close to make sure that it doesn't get too much air pressure. Okay, so this is the blower to begin with. So hopefully you could tell that was a really quick inflation of the reservoir, and now it's idling. So there's a special drive that was put in that controls the speed of the motor. Originally it was a single speed motor. It's now got a drive which makes the motor speed up and slow down according to how much demand there is. Okay, I'm going to turn that off again so that it's ready for the hydraulic engine. It will gradually come down. So here we have the hydraulic engine, which, as I said, is extremely unusual. So you've got this view, which is really good because with the panel here, which I've taken out, you won't be able to see any of this. So let's actually have a look around this side. Okay. So the hydraulic engine, now it was restored in 2020 by James Richardson Jones at Duplex in Surrey. and it's basically a reciprocating engine. So there is a cylinder which is here, and the cylinder rod, that's a guide rod to make sure that it can take the weight of the work it's doing, so it doesn't bend the cylinder rod. It's got a straightforward cylinder system, it's reciprocating, and there is a valve down here which allows water to either to go to either end of the cylinder, or indeed to leave the engine and go around. So originally the water came through this pipe here. This valve would have been opened and the pipe actually came from a reservoir way up on the hill behind Moccas, so it's a few miles away. That obviously doesn't work anymore, so what happens now is that the water for the system recirculates. There's a tank there, there's a pump just down here, and you'll hear in a minute that it's all a recirculating system. Before we turn it on, I would just like to show you something this side, which is why this view is so important. There's a valve, a special clutch valve in here. Very clever. James had to make multiple parts for that in order for this to work. But basically what happens is, as the reservoir fills, this system moves. As the reservoir, this is attached to the top of the reservoir fills, and basically this moves and it closes eventually. This moves across and it will close this valve, so that the hydraulic engine slows down, but it has to be able to idle. So it doesn't close it off completely, but it just slows it to an idle, and then the reservoir stays inflated. And you could, I mean, we're not going to do that now, but you could play on the organ with about half of the stops. It would be fine. Any more than that, it tends to be unable to handle the airflow really, and the instrument would run out of air. The feeders, this arm here, which, have a look at this view here, this arm used to be a lot longer when it was hand pumped. We don't know the history exactly going back to the beginning of the instrument, but at some point this was reduced in length. Also, the hydraulic engine used to be on that point there, which would have been a lot more sensible because it's near to the central pivot. It was moved to here, and when it was restored it was decided it would be left here where we found it, rather than put back there. So yeah, it's good to see it working now, and what you will see when it starts is the two bellows. These had to be re-leathered when it was restored. The two bellows will work. They've got one-way valves in them, so rather like when you blow up a balloon, the air will only flow through the bellows into the reservoir. It will not come back out again. So that makes sure that the air can stay in there. And then, as I say, it's not a hugely quick thing. It's a lot slower than the blower. But it's fascinating to see it working. So you'll notice that a little bit of water leaks out. That's inevitable. That's nothing to worry about. I just have to dry it up when we finish the demonstration. So, okay, I'll start the pump and hopefully everything will work properly. Okay, and it will now, of course, gradually deflate the reservoir. It's fascinating, isn't it? I mean, it's an amazing thing to see. Now, James, who did the restoration, is a very, very clever engineer, and he engineered all of this. It's all bespoke work that he did for this whole thing, this whole mechanism here. And bearing in mind he was in Surrey while he was doing this, he had to get all his measurements and then come to the church to fit it. He also did all the electronics, so there's quite a complicated control system here that does all the lights, the heating, and the and the engine and the organ as well, the blower. So yeah, it's all good. So what you can see here is part of the tracker system, tracker action. There are trackers and there are stickers in an organ like this. So the tracker rods pull. So for example, on the great organ here, this is, you can see it starts over here but ends up being spread out to here. This is because the pipes are all wider than the soundboard is wider than the manuals. So it just has to be spread out, and the way it works is this. This is called a splay beam, and essentially that means that you've got the pipes are above here, but the actual key is sort of that, so it gets it across like that. This is a tracker rod because it's pulling down. If I then do something on the swell, that's a sticker there which is being pushed up. And interestingly, what you're seeing here is not the same as you would have seen on my film, I don't think. You can see these are all nice and shiny, so these are new. These are all put on new. These are all threaded and they're all adjustable. And these are called stickers because they push. That's what you call them in a tracker action organ. But they all had to have these new threaded put in. Now these are obviously a lot higher. They were literally finishing around here, so I was convinced they were too short. So they've been extended a lot. It should be physically impossible for an organist to derail the mechanism now. So that's really exciting. What we also can see is the great swell coupler, which is this. So it basically clamps the two together so that when you play on the grate, you've got the swell as well. So it combines the two, and you've obviously got this here, which is nice, where the two manuals are working at the same time. So this is what I like about this organ. You obviously get organs that have a lot of electronic systems and you know, sort of semi-mechanical, but everything here, apart from the lights and the blower, everything here is completely mechanical. Over on this side you can see the, I hope you can maybe see this, the rotating part of the drawer on the 12. That is simply the beginning of a journey to get from here to moving the slider, which moves that way on the soundboard. So it's pulling here, but it moves that way up there. And to get up there, if you've seen my film, you'll know it's an amazing journey it goes on to get that all the way. On the back wall, if you can actually see on the back, well, it's nearly on the back wall, they are tracker rods which are for the swell, and you can't really see them moving, but if you've seen my film, I think there was a photograph that I took of those tracker rods when you could see the whole wall before it was covered up with other organ components.